Your router says 46 gigabits per second. Your phone is getting 200 megabits. Your internet provider isn't cheating you. Your router isn't broken. The 230x gap between what's advertised and what you actually get is governed by an equation from 1948, and once you understand it, you'll never look at a Wi-Fi spec sheet the same way. This is C equals B times log base 2 of 1 plus senior. It's called Shannon's theorem. If log base 2 or senior sounds scary right now, don't worry. By the end of this video, every symbol in this equation will feel obvious. Here's the plan. First, meet the man who invented it. Then we'll break the equation down into its 3 pieces. Then we'll plug real numbers from your house and watch your Wi-Fi collapse. Compare it to fiber and see why fiber wins. And finally, see why this same equation governs every signal in the universe, including the neurons in your brain. Let's go. In 1948, a 32-year-old engineer at Bell Labs named Claude Shannon published a paper called A Mathematical Theory of Communication. Before this paper, engineers thought a noisy channel meant you'd always get errors. Shannon proved something nobody believed, that for any channel, no matter how noisy, you can transmit data with 0 errors as long as you stay below a specific speed limit. And then he gave them the equation for that limit. This single paper created modern compression, error correction, cryptography, and the entire internet. Shannon also juggled while riding a unicycle through the halls of Bell Labs. He's one of the most underrated geniuses in history. Here it is. Channel capacity equals bandwidth times log base 2 of 1 plus the signal-to-noise ratio. Only 3 things matter. Bandwidth, how wide your frequency range is. Signal-to-noise ratio, how clean your signal is compared to background noise. And the log base 2, which is where the magic lives. Bandwidth is like the width of a highway. Wider lanes, more cars per second. More frequency range, more bits per second. A phone call uses about 4 kilohertz of bandwidth. FM radio uses 200. Wi-Fi 6 uses up to 160 megahertz. Wi-Fi 7 doubled that to 320 megahertz. And fiber optic cables? They use terahertz of bandwidth. About 300,000 times more than Wi-Fi. This is the first reason fiber crushes Wi-Fi. Way more highway. Signal-to-noise ratio is your clarity. In a silent library, a whisper carries. In a crowded market, you have to shout to be heard. Same vocal cords, totally different senior. Wi-Fi signals get weaker the further you move from the router. Walls absorb them. Microwaves interfere. Your neighbor's router screams on the same frequency. All of this destroys your senior. And senior is measured in decibels, which are logarithmic. 10 dB means 10 times. 20 dB means 100 times. 30 dB means 1,000 times. Every 10 dB is a 10x jump. And here's where the equation gets brutal. The log base 2 means doubling your signal power doesn't double your speed. It adds 1 bit per second per hertz. 1. To go from 1 gigabit to 2 gigabits, you don't need twice the power. You need exponentially more. To go 10 times faster, you might need 1,000 times more power. This is why you can't just turn up the Wi-Fi to fix it. Physics says no. So how does Wi-Fi 7 advertise 46 gigabits per second? Let's break it down. That number assumes the maximum 320 MHz channel. The newest modulation scheme called 4K QAM, which packs 12 bits into every symbol. And here's the trick, 16 simultaneous data streams using MIMO, which stands for multiple input, multiple output. MIMO uses multiple antennas to send parallel data through the same air. Each stream is its own Shannon limited channel. 16 streams means 16 times the capacity of a single channel. So that 46 gigabits? It's the absolute physical ceiling, with 16 antennas, perfect signal, in a lab. Your phone has 2 antennas. So your phone's actual maximum on Wi-Fi 7, verified by Intel specifications, is 5.76 gigabits. Already an 8x cut from the box. Let's actually plug numbers into Shannon's equation for one channel. Wi-Fi 7 at 320 MHz, with great signal, senior of 35 decibels, which is about 3,162 in linear ratio. C equals 320 million times log base 2 of 3,163. That's 320 million times 11.6. About 3.7 gigabits per second. Per stream. In perfect conditions. Now move to the next room. Wall in the way. Senior drops to 20 decibels, 100 to 1. C equals 320 million times log base 2 of 101. That's 320 million times 6.66. About 2.1 gigabits per second. You just lost 40% of your speed by walking 5 meters. Now upstairs bathroom. Senior drops to 10 decibels, 10 to 1. C equals 320 million times log base 2 of 11. That's 320 million times 3.46. About 1.1 gigabits per second. You lost 70%. Same router. Same plan. Just physics doing its job. Here's the betrayal hidden in Wi-Fi 7's marketing. To hit 46 gigabits, the router uses 4K QAM modulation. This means it represents 12 bits per symbol by placing 4,096 different signal points into the same channel. Each point has to be distinguishable from its neighbors. When senior is high, the points are clearly separated and the receiver can tell them apart. But the moment noise creeps in, those tightly packed points start blending together. The receiver can't tell a 1011 from a 1010 anymore. Errors explode. So the router does what's called rate fallback, it drops down to a simpler modulation. Maybe 256 QAM or even QPSK. Each fallback chops your speed in half. Sometimes by 4x. This is why 4K QAM only works when you're sitting next to the router. The moment you move away, Shannon's law forces the system to slow down. There's no software fix. There's no firmware update. It's the law of information. Now plug fiber into the same equation. A single optical fiber has usable bandwidth of about 50 terahertz. That's 50 trillion hertz. Roughly 150,000 times more than Wi-Fi 7's widest channel. Light traveling through glass barely loses energy to noise. Senior easily exceeds 50 decibels, 100,000 to 1. C equals 50 trillion times log base 2 of 100,001. That's 50 trillion times 16.6. About 830 terabits per second. Per fiber strand. Thinner than your hair. Fiber isn't faster than Wi-Fi because of better engineering. It's faster because the same equation gives radically better numbers when you have more bandwidth and less noise. Shannon's law isn't choosing sides, it's just doing the math. Wi-Fi has hit its physics ceiling. Fiber hasn't even started. Here's what makes Shannon's theorem one of the most profound results in all of science. It's not a statement about technology. It's a statement about reality. No future invention can break it. No quantum computer. No alien civilization a billion years ahead of us. Every signal, anywhere, ever, is bounded by C equals B times log base 2 of 1 plus senior. When SpaceX talks to Starlink satellites, they obey this equation. When NASA talks to Mars rovers, they obey this equation. When neurons in your brain fire signals to each other, they obey this equation. When DNA copies itself, every base pair transmission obeys this equation. It is the law of information itself. Shannon discovered the speed limit on knowing. So look at your router again. The 46 gigabit on the box isn't a lie. It's the absolute maximum, with 16 antennas, perfect signal, lab conditions, that doesn't exist in your house. What you actually get is whatever Shannon's equation allows after walls, noise, distance, and the fact that your phone has 2 antennas instead of 16. That's not a defect. That's not your ISP cheating. It's an equation from 1948 doing exactly what it's supposed to do. The next time someone complains their Wi-Fi is slow, you can tell them. It's not the router. It's not the company. It's the universe itself, putting a cap on how fast information can travel through air. But here's something even crazier. Shannon also proved that even on a garbage channel, full of static, full of errors, you can still transmit perfect data, with 0 mistakes, as long as you stay below C. The math of how that works is called error correction, and it's the reason your video call doesn't fall apart every time a packet gets lost. That's the next video. Subscribe so you don't miss it. Comment a log base 2 if you made it this far.